This week's project is a 2-inch by 2-inch maze puzzle. It will start with a sketch, be made into a 3D model, and ultimately you'll program it to be machined from the acrylic on the vertical machining center. Start by opening the website mazegenerator.net. Next, set the width to 10, the height to 10, the inner width to 2, inner height to 2, and click Generate. Check the As Lines box and then select SVG or Scalable Vector Graphic from the drop-down menu. Click Download to save it to your computer. When starting a new design, especially when using multiple components, it's important to always save your document and give it a unique name, something that you can remember. In this case, I'm going to name mine Maze S1 2003 for Maze Semester 1 2003. This will be a multi-part or component assembly. So I'm going to create my first component and I'm going to name it Maze Base so that I can readily identify the component in my design assembly. Next, I'm going to create a base sketch on the XY plane, and I'm going to import my scalable vector graphic that I generated earlier into Fusion 360. This will become the basic design that I will use for my maze. We'll be using the sketch center to center slot command. Fusion 360 doesn't have a keyboard shortcut by default, so we'll define one. So open the sketch command menu, select slot, select center to center slot, click on the three dots, and then open the command. Assign the letter Z or any letter you wish, and then click OK. The imported design represents the center line of the slots that we wish to machine into the maze. Select Z, create your first slot, and make the width 1/8 of an inch, 0.125. Then draw your additional slots, and instead of putting the numerical value, use the variable D1. Do this for all of the slots on your maze until you are completed. It will take a while, probably about 10 minutes. I sped up the video about 20 times. I really wish I could work this fast. It's important that you make sure that you have all of the slots created. If you miss one inadvertently, your maze might not be solvable. Next, we have to create the starting and end point for the maze. The starting point generally is at the top, and you'll create a slot, and you'll also create a circle. The circle is important because we'll use that to generate a pocket that's deeper than the rest of the maze. That way the ball can rest in it. The ending point will be done similarly. In this case, I'm creating a rectangle or a square in the middle of the maze, and I'll put filleted corners on it. Offset the ending pocket by the 1/8 inch value from the center line of your other slots. That'll keep it looking relatively uniform. Also, put a fillet that's half of D1 or 1/16 of an inch, and that will make it look nice. In this case, I only filleted 3 of the corners, but I'll come back later and I'll do the 4th one. The reason being is that I needed to be able to machine that pocket deeper, and I wanted a uniform corner. To tie the slots into the ending pocket, I created some construction lines that allowed me to generate a slot that would go from the ending point of the maze to the middle of my rectangle. Next, we'll use the 2-point rectangle tool to define the outside edge, and we'll space it from the outside edge of the slots by the value D1, or 1/8 of an inch. Now with the sketch complete, it's time to begin extruding our 3D model. In this case, we're going to select our entire model and we're going to extrude it to a negative quarter of an inch, or minus 0.25, to represent the thickness of our material, or our acrylic in this case. Now with your sketch visible, snap to the top plane. Select all of the slots inside your model and cut them to negative 150 thousandths, or minus 0.15 inches. This will define the depth of the slots. Next, we're going to cut out the starts and the stop points on the maze. So select your start and cut it to negative 170 thousandths, or minus 0.17. Pan out and then zoom into your end point and select that area also. As I mentioned earlier, I didn't really like the sharp corner on the entrance into the end point. And so I came back into the sketch and I added an additional fillet to smooth out that pocket and make it look more professional. Now I can rotate the model and the fillet makes it look a lot better. I have found that if I add fillets to all of the corners, that the model will machine better. It also plays better. So here I'm going to select the edges, and then using the window selection, I'm going to go from the bottom right to the upper left, and I'm going to select all of the vertical edges. I'm going to add a 20 thousandths fillet to that, so 0.02, and that should look pretty nice. Fillet the 4 outside corners, use the value D1, or 1/8 of an inch, to give it a finished look. You may have noticed that your model currently is 1 7/8 square, 1.875. We'll use the scale command to bring it up to the finished dimension of 2 inches square. We're going to do a non-uniform scale, and we'll scale each axis, x and y, as 2 divided by 1.875. Z will remain 1. This will make it 2 inches by 2 inches by 1/4 inch thick. In part 2, we'll go over the machining of this part.